Mark, it's been so long since we've been together. I'm so happy to see you.
I mean, it's great to see you with some clothes on.
That's fair. That's fair. No wig this time. What an appropriate shirt, Superman, because you're solving a problem that people have long suffered from. And that's what we're talking about. We're going to talk about how you solved that problem of automatic refresh from a Lakehouse to the SQL Analytics Endpoint today on Tales from the Field.
Today's gonna be a good day. Wake up. Today's gonna be a good day. Wake up. Today's gonna be a good day. Wake up. Today's gonna be a good day.
So, Mark, you wrote this absolutely amazing blog. I featured it on one of our Azure Data Community roundtables recently. And what it talks about is how we call an undocumented REST API to be able to refresh the SQL Analytics endpoint after you do an ETL process in the Lakehouse. So, could you talk to me a little bit about what situations customers face and what causes the need for this REST API to be refreshed?
So, what we see in the field and what we see customers doing today is they're using, in Fabric, they're using the Lakehouse architecture, and we're pushing them towards that, and that's great and that's fine. And they're loading things into the Lakehouse, they're using pipelines, they're just uploading files, they're using Spark notebooks. They're creating their delta tables. They're building their bronze or their raw layer up, and and then they try and query that in the SQL endpoint to try and then either move it into a lakehouse to do some sort of transformation. And what we're seeing is that people say the data isn't updated or it's out of date.
And to be fair, the data is there. Like if you were doing everything in the Delta Lake, if you were just utilizing notebooks, if you were querying this over Spark, the data is there. It's not that the data is not there. It's just that there's some type of metadata refresh that's occurring between the Lakehouse and the SQL Analytics endpoint.
Yeah. Okay. So I'm going to let you into a bit of a secret. So
Okay. I won't tell anybody, I promise.
okay, just between you and me, we have not kind of told people about something, and we actually, if you now go into your lake house, and I haven't, even if we did some prep before this, I haven't even shown you this. If you go to your SQL endpoint and you hover your mouse over the refresh icon, you'll actually see that says metadata refresh now. And there's
Oh,
also another little feature we've snuck in there, which is in the properties of the table in the SQL endpoint. But I digress. I'll show you that later. But today,
okay.
you'll put things into the Lakehouse, and we will then make it appear in the SQL endpoint. And there is this process that sits in the middle, and we call that metadata sync. But don't tell
Okay.
anyone about that. That's running every few seconds, and that's picking up any changes in the delta log. So we're going to be very clear. It's the delta log we're looking at, not the volume of data that's changing, but the number of delta log changes. We read the delta log, and then we tell the SQL endpoint this Parquet file is now part of your table, or this Parquet file is not part of your table if you did a remove or a delete vector. So the SQL endpoint is actually pointing at those real Parquet files in that Delta table. But there is a very short amount of time that exists between you writing it and the Delta log updating and us updating that in the SQL engine.
Well, and that's how we put the ACID properties, the transactional consistency into Delta, correct? Is that what's happening is we have a transaction, it commits to a log, and once it commits to that Delta log, everyone else who's using a notebook or using that Spark level experience can see and utilize that data.
So from a Delta point of view, yes, that's what they see. As soon as that table has been updated, effectively the log gets written or copied over. So they see the or renamed, they see the new version of that log, and then we essentially pick up on that change, that new version of the log, and we then make that change in the SQL endpoint.
Okay. And so what we have to do is we have to get that metadata change from the lakehouse, from the logged information to reflect to the SQL Analytics endpoint. So that way, when I then go in and I connect in SQL Server Management Studio, I can then query and access my tables. Or if I want to use another experience like a Dataflow Gen 2 that uses the SQL Analytics endpoint, my data is there and is in place. And so what
Yeah,
we find is customers are doing all these ETL operations overnight, and the SQL Analytics endpoint, it's serverless, right? It goes to sleep. And so it's not getting refreshed automatically as these things are occurring. And so the code that you've got allows us to be able to refresh that SQL Analytics endpoint. So when users come in the morning and they want to access their data, it's all sitting right there and it's ready for them to access it.
Yeah. So in the worst case, and this is this is stuff I've seen at customers, there are gigs of Delta logs, gigs, thousands of changes per table. And the laws of physics are against us. We can't make that change instantaneous. So there can be a bit of a delay. So, but the sync allows us to say, after I've finished all the updates, run the REST API or the notebook, and then when it's finished, I know my SQL endpoint is got the very latest data. And then if I want to run some SQL or I want to do something afterwards, the data is going to be up to date and refreshed. Why don't you show me?
Let's not just talk about it. Let's get over and let's look at this great content that you built. All right, so here we are. We're in our Fabric workspace. And so I'm sitting here in the notebook experience. I've got my EDW Lakehouse, and you can see I've got a couple different tables in here. Now, what we could do is I could go ahead and I could delete this table. That's going to cause a delta log operation to occur to reflect that that table is no longer there, correct?
That table will no longer exist. There will be no delta log there anymore. No, but it is a good example because we have to pick up on that.
We still have to pick up on that change. Excellent point. Okay, so that now I haven't woken up my SQL Analytics endpoint just yet. It's still asleep. It had a good night's rest, but now a table is gone, but it doesn't know about it. Now, looking at your script, one of the things that was in there was the pimp install semantic link, but I'm running Delta 1.3 and higher on my Spark instance. As a matter of fact, we looked at this earlier. We went to my overall workspace. I went to my workspace settings, over to my data science engineering Spark settings, and I could look at my environment and I could see which setting of Spark I have. I'm using Spark 1.3. So I'm sorry, 1.3, Spark 3.5, Delta 3.2. So I don't even need this pip statement for the install semantic link. The semantic link is already in there. So what I can do is I can jump straight down to your code. I can go ahead and run this. And what I did was I actually split your code up into two pieces, because as we walk through this, the first thing that we did, there were a bunch of import functions that we needed to be able to have so we could actually run the code. And then you have a function that you're creating right here, pattern truncate string, that we're going to use a little bit later, but we're not really using up front. And then you can see you're getting the tenant ID, the workspace ID, the Lakehouse ID, which is a GUID associated with it, and then the Lakehouse name. And you're constructing your SQL Analytics endpoint. We're doing that right down here. And you're also setting this in JSON, because part of what we're doing is we're creating a URI and then we're creating a JSON payload where we have our command as a type of metadata refresh command. Now, when I come down a little bit lower, I dropped that table, sentiment 3, it's gone. We've already agreed this is going to be a delta log change. And if I wanted to, I could drop this table if it exists. This won't cause an error, even though the table's no longer there. And then I can say, select this into this data frame, write it out as table sentiment 3. Now, the reason I've got the second batch of your code down here is this is the really important stuff right here. Your response equals client.post URI, JSON, and payload. This is where we're calling that metadata refresh. And then the data response, we're just getting the text response from there. Now, really, we could almost stop right here and we would be able to refresh the Lakehouse. But what you did in the demo was you took this text, you took the batch ID for this cell of information that we're going to execute, and then you did a while statement to be able to pull out some information from that JSON so we could see if the table is updated. So I'm going to go ahead and run this. This will create my sentiment 3 table in a data frame, and then it's going to write it out as the sentiment 3 table. Now, it's also going to call a refresh from the SQL Analytics endpoint. So even though I haven't connected via SSMS, I haven't connected via any GUI tool to be able to access that analytics endpoint, I haven't woken it up yet, we're going to cause it to wake up and refresh and get that data. Now, there's 8.8 million rows in this table, so it's not a small table. And as we can see, it runs in about 30 seconds. And I can see right here, the table sync state is a success. Now, right here, it's not run, but I didn't do anything to those tables. So it's not necessarily needing to be run. Had I made changes to this, had I done some CRUD operations, update, insert, delete operations, then that would have created delta logs. And the SQL Analytics endpoint, that refresh would have had to scan all those delta logs to be able to get there. As it was, we dropped a table, we recreated a table. It just had these two items to refresh. But if I connected in SQL Server Management Studio right now, I would see that my sentiment 3 table is already there. I didn't have to wake it up and then wait for that refresh process to occur, correct?
Yeah, actually, if you comment out that line that says that creates that table, and you run this again, you'll see that that table will just be there. You'll have the date of the last refresh, and it will be not synced. Um, and
And
I
I'll just pull
think
that code out.
and you actually see that there's actually a sleep of 1 second. So essentially, it took a second to do this, to do the sync.
Excellent. So it's not a ton of overhead for us to be able to add on to the process. And it's a good idea, especially if we've got a complex ETL process going and we want that data to be ready. I've had customers before where they may have had a notebook run and then they wanted to have a Dataflow Gen 2 run. And that Dataflow Gen 2 is dependent on the SQL Analytics endpoint. So instead of having a wait process or a secondary process to be able to check that the data has the amount of rows they were expecting or is in the format they were expecting, they could just use this command to be able to refresh that, and then their data is in place. They can go on to that next process that may depend on the SQL Analytics endpoint to be able to get that data and
Yeah,
be able to pull it out,
there
correct?
is I've got a slightly hackier solution that I did put together in another cell, which was I can run some uh, I can run some SQL that counts a number of rows in Spark, so from the Delta table, and I can run exactly the same code against the SQL endpoint, and I can compare the number of rows. And if the number of rows doesn't match, then it hasn't refreshed it. So that was like an earlier version of this before I'd worked out where the API was. So it's a similar process, but this is much nicer. And if it does error, it will tell you what it's errored on and why it's errored.
Well, and one of the things I wanted to show folks is this doesn't loop per table. But it also doesn't need to. It's going to take every single item and it's going to refresh it. So for example, if I were to paste this up top and we're going to drop this table, we're going to recreate this table. And then I'm also going to do an insert into sentiment 2 to be able to add another 8.8 million rows there. While this script will run for a little bit longer, it was 31 seconds the first time because, again, we're dropping a table, we're creating a table, and then we're loading additional rows in. When I come down here to the refresh and we see this printed out, typically I'm only getting the refresh for the latest and greatest item. And so if people were to run this script and go, hey, I'm looking at the text output and I only see on the text output that here's one success state, that doesn't mean that anything else has failed. And it doesn't mean that there wasn't changes on other objects. It just means that as this process ran, it's looking at the latest batch ID associated with it. Because you can see right here, we had sentiment 3 first, we had sentiment 2 second. And while sentiment 3 shows that the table sync did not run, sentiment 2 shows that it was a success. But really, it's only going to show the information for that last table because we would have needed an iterative batch to loop on each table. And the thing to keep in mind is people don't need this for the every single step of their ETL process. Really, you just need to do this by the end of your ETL process.
Yeah, just before you want to use the data from the SQL endpoint. It's the only time you ever need to run anything like this.
Absolutely. And you were telling me something fascinating. So if I come over to my Lakehouse right here, let's go ahead and we'll do a quick refresh. I can see that, and I'm still in the Lakehouse. I'm not in the SQL Analytics endpoint because I can see my table showed up here. But if I come over to the SQL Analytics endpoint, that right there was the refresh command essentially that we're
Yeah. So
sending.
if you hover your mouse over the little refresh next to the cog, you'll see that is.
Oh, right
If
here.
you zoom it on other tool, you'll see that.
Oh,
Yeah,
metadata sync.
that's sort of new. And then if you click on the three dots on one of those tables, and then go to properties, you'll also see that we've added last sync updates from OneLake. So that's the last time we've updated this table.
Oh, fantastic. I love that. That's a little bit of fabric magic right there. Okay, so no longer do people need to worry about that delay. What you need to do is have that refresh of that endpoint. If we add this to our processing at the end of our notebook ETL process, we can continue just fine moving on and using those other items that are dependent on the SQL Analytics endpoint. And also have that data ready for anybody who's going to come in via SSMS, Azure Data Studio, any external tool looking at the data and being able to query it. Now, this was never a problem if you were using a notebook, but it was only if you needed that metadata refresh to be
Well,
in place.
I mean, since it's just you and I talking, there is something else I wanted to share. Is that it isn't just the metadata sync doesn't just update the SQL endpoint. It updates the semantic model. So if you want to do a Power BI report, um, that's how those
Yeah.
tables get into the semantic model is the metadata sync.
Mark, you just blew my mind. Wow, that's a really big thing to know is we're not just hitting the SQL Analytics endpoint, we're hitting the semantic models, the direct lake semantic models that are dependent on that table,
Yes,
correct?
yeah, and that's why there are
Wow.
certain things
Okay.
you can actually turn that off, and have that automatic refresh turned off. I think that's at a workspace or a Lakehouse level. I can't quite remember. So it doesn't need to be running, but yeah, if it is running, that's how you automatically get tables and new columns and changes in the metadata added into the semantic model.
I love it. Mark, that is absolutely fantastic stuff. Okay, so you know where we want to keep this conversation going down in the comments. Sound off. Is this useful? Do you have a problem that this is going to solve? We want to hear from you, and more importantly, Mark wants to hear from you because I'm going to let Mark know whatever these comments are, and I will have his cell phone number, but I'm not giving that out. He wouldn't like that.
No,
He's Superman, but nobody can escape those phone calls.
I'm more
All right.
Clark
Thank you
Kent.
so much for joining us on Tales from the Field.
All right,
I
thank you for having me
oh
again.
oh oh hold on a second. I see the difference. Thank you so much for being here, Mark. Take care
Right,
of
cool.
everyone.
Thank you very much for
Be good
having
to
me.
one another.
Take care.
Bye, everybody.
Wake up, today's gonna be a good day.